All right. So if you want to take a notebook out or anything like that, make sure you do so right now. We're going to go ahead and take a look at this problem right here. Let's see if it actually focuses.
That's from my other class.
Oh, interesting. It doesn't do that very well. All right. So for a science project, we've got Raul who wants to find out which types of grass grow in Colorado. He looks at lawns and wild grass in the areas where he lives and identifies each kind of grass he sees, keeping track of which is the most common. So what is Raul doing? He's just, is he doing anything to the grass?
No.
Is he applying any treatment, any fertilizers?
No, he's not asking the
No.
questions.
And he's not asking the grass any questions, so that's going to be a observational study. Cool?
Yep.
We're good with that? Okay.
Easy.
All right. So Jorge wants to find out whether people at Lincoln prefer Chipotle or Qdoba. He selects a random group of students by assigning each student a number and using a random number generator. He gives these students a questionnaire about their favorite burrito restaurant. Is this a survey, experiment, or observational study? Why is it a survey?
Because he's asking questions.
He's asking questions, right? So it's going to be a survey. We're still good?
Yeah.
Okay. I don't want you to get the last light. Okay. All right, so Rita wants to find out which paper towel brand is the most absorbent. What does that word mean?
Hey, it holds up. It gets the most water.
Right, like those paper towel commercials, right? Which one absorbs the most? So we want to know what is most absorbent. She buys one of each kind of paper towel from her local grocer, for local supermarket, and she measures the amount of water each will absorb.
That's an experiment.
Is it an experiment?
Yes.
Why?
Because there's different control groups, right?
So there's a key word when we're talking about experiments.
Treatment. Oh,
Okay, that word is treatment. Okay? So we're talking about experiments. Treatment is the most important part of that. Does that make sense? Okay? So if I'm applying some sort of treatment, what is the treatment here? What's the treatment here?
The water. Oh.
No, amount of water.
Isn't it the brand of paper towel? Right? Because they're all different. So the treatment is that I'm having different brands of paper towel presented. Does that make sense?
Yes.
Okay, next one. Okay, Marty wants to see if Skittle bags have more green Skittles than any other color. He buys 100 bags and sorts each bag by color and makes a bar graph of his finding. What is this?
Observational experiment.
Okay, so what are the three options potentially?
Survey.
Survey, so did they ask the Skittle questions? No. He could, but I don't think they would answer. Okay, did they do an experiment on the Skittles? Did he apply some sort of treatment to the Skittles? No. Did he observe the Skittles?
Yes.
What did he observe them for?
To see if they had most Skittles.
Their color, right? He sorted them by color, so he observed their color, so this is going to be observational. Okay. Daniela is an engineer. She wants to test which combination of chemicals and paint stands up best to rain. She mixes several different paint buckets to be tested on a variety of walls. After waiting 6 weeks of rainy weather, she observes each of the walls she painted. What is this?
Experiment.
Did they ask questions?
No.
Did they apply treatments?
Yes. Yes.
What is the treatment?
The combinations.
The different chemicals in the paint, so that's the treatment. Okay? So this is going to be an experiment. All right. For a certain data set, which is normally distributed, the mean is 100 and the standard deviation is 10. What is the probability that a randomly selected number is between 80 and 110? Will you do me a favor? Will you get me an eraser off of the backboard and bring it up here? Okay, so go ahead and take a couple minutes to work on this. Clara's going to give me an eraser so I can put it on chalk, and that's going to display the rest of the video.
So it's 100 and then 110 deviation.
So if I'm taking a look at this, what diagram am I going to be using? Thank you. What diagram am I going to be using?
One of those things that go.
One of these things?
Yeah, I don't know.
So I'm always going to be using the normal distribution. Am I going to give you this diagram?
Yeah.
No. You have to have it memorized. nice.
So
Okay.
let's get one of those things.
Okay, so 1, 2, okay.
Miss Doria, let's get one of those things that me and.
What do you mean? You want a protractor?
Yeah.
That makes you feel happy.
Wouldn't it be 95%?
Okay. All right, so I know this diagram is what? 34. Is that showing up? That's not showing up. Okay, this is 34, 34, 13.5, 2.35, and this is out to 0.15. Right? 13.5, 2.35, and 0.15. All right, so here's the question, right? I want to know between 80 and 110, what goes in the middle? What goes in the middle? Why? Because it's the mean. Okay, and what goes out on each side? You add and subtract 10. So this is 110, this is 120, this is 130, 90, 80, 70. Okay, so what are they asking me to take a look at?
Between 80 and 110.
Between 80 and 110.
Is to find out what the percentage is. What the probability.
So 80 and 110 is this right here.
So where should you just add that up?
34 plus 34 plus 13.5.
That's 64. That's 68.5.
What is this equal to?
81.5.
81.5%. Okay. So that's going to be C on this one on the board. Okay? We're okay? Okay, this normal distribution can help you out with a lot of stuff. All right, let's go ahead and take a look at the next one. I know. What about 80 and 120?
Oh.
That's going to be 95%, right?
80 and 120, yeah, so this is like the magic one, right? So if I'm 2 standard deviations out on both sides, I should know that that's 95%. So if they ask me for a 95% confidence interval, I should know that that's 2 standard deviations out on each side. We're good?
Yep.
Good? Okay. Let's do next one. All right, what is the most random way to select a sample of students at Lincoln? So A, select students from all the Algebra 2 classes. B, select all 9th graders. C, randomly pick people in their lunch line. Or D, use a random number generator to pick student IDs. Okay, D is always the best option. And like we've been saying all day, if I am going to have an unbiased sample method, what are the 2 options?
Give everybody. Oh, the hat method.
The hat method, so put everybody in the population's name in a hat and throw it out. Or a random number generator. Now, if you just put the words random number generator, am I going to accept that?
No, you have to explain it.
No, you have to explain it. So step 1, I assign everyone in the population a number. Step 2, I use a random number generator to select my sample. Okay? So please make sure you explain that super, super well. All right, next one. So here, what percent of the sample falls between the values of 20 and 29? And I'm going to email an attachment of this presentation with the video. So if you're freaking out because you can't see it, you're going to get it attached with the video. So here, we've got a mean of 23. So 23 is in the middle. If I were to edit this diagram right here, right, 23 is in the middle. What does it look like the standard deviation is?
3.
3?
So this is just this one.
So then that's 26, 29, and then this is 20, 17, 14, and what are they asking?
The percent between 20 and 29.
The percent between 20 and 29, so how would I do that?
What are we, 81?
So 20 and 29,
You add 34 plus 34.
same setup but on the other side of the normal distribution. Good, so 81.5%. All right, what is the standard deviation of this graph? So I'm going to go ahead and show you over here.
0.8.
So I got 40.9 here, and then 41.2. Do I need to keep going, or do you already know the standard deviation? It's already, what is it?
0.3.
Right, because I know the distance between 2 of them is just 0.3. Cool?
I thought it was 40.9.
Okay. Which data set is the most spread out?
Oh, is that the widest range?
Okay, so if it's the most spread out, it's got the widest range, right? Same thing. So which one of these data sets is the most spread out? So A has a of 7, the number is 20, the average is 45. What are you going to tell me to only read?
The first and the last.
Okay, when I'm looking at most spread out, I'm just looking at the standard deviation. So I have standard deviations of 7, 5, 10, and 2. So what's the most spread out?
C.
C, where the standard deviation is 10.
One day or sad.
What's that one equation?
I don't know.
All right, the z-score we would use for a 95% confidence interval is what? Okay, the z-score on each side. So what would you do on each side for 95%? How many standard
2.
deviations? How many standard deviations for 95%? 2. Okay? So it would basically be like -2 and +2 z-scores to be able to get you the 95%.
Whatever the half ball.
What?
12%.
All right, is that it? All right, what questions do you have off of your review guide? This is where I wanted to open it up a little bit to your questions. What do you want?
Miss, what was that one equation? I don't know if it's still relevant.
I'm recording a review session right now.
Never mind.
Okay.
I'll just wait for it.
Bye.
Okay, what's up? What questions do we have?
For number 5, how do we?
Yeah, number 5.
Number 5, do you want to go ahead and get the lights on since we're not going to use the beacon anymore because it doesn't show up? Yeah, it's fine. All right, so number 5 on the review packet. What does that say, Christian?
It says a scientist needs to, so the whole question?
Sure.
A scientist needs to estimate the mean of population using sample size of n equals 324. The sample mean is.
I take it
340.
back. It washes it out. Turn it off. Okay. So you need the I heard you. Number 5. Okay. So basically, on the test, they're going to give you your formula for a confidence interval,
Yeah, that's what I was looking for.
right? They will give this to you every single time.
Oh, that's
Oh, good.
Okay? All you have to do is be able to identify all the different parts. Does that make sense? What you're looking for is this part right here. So you're not plugging anything in for it because you want to know what mu would be between. Okay? So when I'm taking a look at this, what we do is we take the sample mean. So for your particular problem, I believe the sample mean is 348.
Correct.
And then we would subtract, now sigma is 18, and the sample size is 324, correct?
Yeah.
Okay. Now the question is, what's the z-value? Okay? So here's the thing about statistics that we didn't dive very deeply into a lot, but if you go into higher statistics, they're going to have you, they give you a lot of z tables is what they call it. So you have a z table on your sheet. What is the confidence interval they asked for?
95%.
I thought it was 90%.
Yeah,
Am I wrong?
90%.
90%. Okay, so what is the z value according to your table that corresponds to 90%?
1.645.
So I'm going to plug this into a calculator. Okay? And I'm basically doing the same thing on both sides, but on this side, what am I doing? I'm adding. So, like, for example, when you talk about, like, especially with the presidential elections going on right now, there's all these polls, right? And all the polls are going to give you a confidence interval, okay? This confidence interval helps them determine, like, hey, we think, this poll is accurate plus or minus 3%, right? This is how they come up with that, okay? Like, something like this, I should say. Probably a lot more sophisticated, but something like this, all right? So I'm literally going to put this in my calculator. I believe this is, 346.355, if I remember right. And this is 349.655. Yeah. I'm adding this together. Or 645, this is 645. There we go. Okay, so 38 minus this was the 346.355. 348 plus this is this. So basically what this says is if I've got my statistic, my sample, right? I am 90% sure that the average for the whole population is between these two values. That's pretty cool, right? Because here I think we sometimes believe that statistics can't be very accurate, but we've got ways to measure how accurate it is or isn't. All right, other questions off that review sheet? Is there anything you wanted to review off of that first instructional task with the strictness survey?
To see how to measure how parents were strict.
Right, you've got to make sure, remember if you're ever asked to write questions, you need to make sure you're writing good questions that don't have a bias or aren't vague, right? Like, are your parents strict? Well, nobody knows what that means, so that question's not going to give me accurate data, right? So I need to decide what strict means and then make sure I ask questions that go along with that. Does that make sense? Yes? Okay, you got any questions back there? None? Do we feel confident calculating a z-score? No. Okay, no, this is good. So what is a z-score? What does a z-score tell me? Do we need to review what a z-score tells me?
Yes.
Yes? It is not the range. The standard deviation will help me determine how wide the range is. Now when I'm taking a look at a z-score, it's related to your normal distribution. Okay? So I know that my average here is in the middle, mu, correct?
Yes.
Okay, and I know out here I am 1 standard deviation to the right. Here I am 2 standard deviations to the right, and so on and so forth.
So means each is a z-score, right? It's its own.
These are these sigmas, right? -1 sigma, -2 sigma, -3 sigma. So if I have a z-score, Christian, I think what you're saying is they're like your z-scores.
Oh yeah, it's like 1 sigma would be 1 z-score.
So a z-score here is 1.
Yeah.
So if I have a z-score of 1, what that means, I'm gonna put the percentages in here, right? This is 34, 34, 13.5,
It's
2.35, 0.15% over here, right? I'm telling you, if you do this enough, you just get it memorized.
Yeah.
Okay? All right, so what a z-score of 1 tells me is that I'm doing better than all of this percent of the population.
So it's a percent.
So basically it helps me determine, like a z-score is a number that's like a percentile, but just expressed differently, right? So for example, if I have a z-score of 1, it's saying, and assuming I have a normal distribution, right? Not all distributions are normal. But if I have a z-score of 1 in a normal distribution, that means I did better than or equal to 84% of the population. And that's pretty solid, right? What if I had a z-score of 0?
You did 50%.
You did average, right? You're in the middle. Okay? What if I had a z-score of -2?
You did.
You're below average.
I'm in the bottom 2, like, I'm only 2.5%. Only 2.5% of people are below. You could say you suck depending upon how rude you want to be. Yeah, totally. Okay? So when I'm calculating a z-score, there's a formula for it. Okay? So the z-score is equal to the number that you're looking for minus the average divided by the given standard deviation. You should be given all 3 values before you're expected to calculate a z-score. Is that helpful?
Yes.
So
Yes.
it's z equal.
So your z-score is your number minus the average divided by the standard deviation. So for example, you want to look in your review packet at a z-score? Yes? Okay. So one of the places that we're looking at z-scores in your review packet is going to be with the tests, right? So I have, we want to calculate the z-score for maybe the algebra test. Okay. So the algebra test, what was the given average? What was the average of the algebra test? 84? Okay. What is the standard deviation? What was the standard deviation? Doesn't it give it to you? Let me see. Okay, so for the algebra test, you had, no. So for the algebra test, we have an average of 76, a standard deviation of 5.1. Now we're looking at Lucy took the algebra 1 test. So Lucy got an 84. Okay, so the x value is going to be 84. This is Lucy's test score. And so basically we're going to decide, did Lucy suck or not? Right? Okay, did she suck on her test? So we have 84 minus 76 all over 5.1. So what does that get you? I think it's 1 point something. Okay. So we actually know, so, we go. 1.6, that means I'm here. So that means I'm probably doing better, closer to like 90-some% of, better than 90-some% of my peers, my colleagues, my counterparts. That's another expression. Does that make sense?
Yeah.
Okay, now what if I had a z-score of negative 1.6?
So you'd be
You'd be in like the bottom 10%.
yeah, so like there's the rest of the population, only 10% people did worse than you.
Only like maybe like less than 10% of people did worse than you. That's no good.
60 people.
What?
Would it be 60%? Wait, how is it
So
less than-
here, less than 10% because up to here,
Oh.
right? Right,
So
you're a
all the-
portion of the 13.5%. Okay. Does that make sense? Now, what if you're given values that are somewhere in between? Right, like on number 7 of your review packet? Do we know how to handle that?
Oh, yes.
Yeah? How do you handle that? Or do you want me to talk about that? Talk about it? Okay. So I will say this, there are far more sophisticated ways for you to do this, but for your purposes, a pretty good estimate will work. Okay? So what do I know about that data? It's like, what, 3.4 in the middle?
Yeah.
And then 4 and 4.6? Okay, and they want you to estimate the percent between what and what? 3.8. So if I look at here, this has got a 0.6 difference. 0.8 is probably about a third in. And 4.2 is about a third over. Okay, so if I take a look at this,
That's like,
maybe a third of each part. Do you guys see that? Okay? Which is not precise, which is why I'm saying it's an estimate. Okay? So what's about a third of 34%? Maybe 12-ish. Okay? And what's about a third of 13.5? Maybe like 4-ish. Right? Do you know what I'm saying? Okay? So 12 and 4 is, so I guess it's somewhere around 16%. And if you look at the more complicated math that they use to solve that, it is about 16 point, I think 8% or something around there.
what if you did 17?
You're going to be fine. So for your test, it's multiple choice, so it should be pretty clear which one is closest.
So is it just all multiple choice?
Not the back ones. The back ones are mostly writing. Okay, are there any other things on your review packet you want to talk about? Maybe the last one or no? Yeah? Okay, what does the last one say? Do you want me to read it? So it gets in the video, because I have a microphone on me. A statistician used the two data sets below to calculate the mean income level in Colorado as $98,000.
Okay.
Fort Collins, and it lists all the data points there, and the Boulder area, and it lists all the data points there. And identify multiple reasons why this calculation is a biased representation of the typical income level in Colorado.
Measures the white.
Okay, so I believe there are not, like, I believe both cities are not entirely white, so that's not entirely
The
true.
richer
But
side of town.
I will give you that the racial demographics in those two towns probably don't match the state, right? And so that could be one method of bias. What else?
It's only measuring like the upper class.
Only measuring like some of the wealthier cities. Okay, what else?
It never.
It's forgetting the rest of the state.
It's forgetting their. Are they both big cities?
Yeah, not really.
Well, city-ish. What about like super rural areas, like
Yeah.
middle of nowhere?
Yeah.
Is that data included?
No.
No. Is this enough data points?
No, it's not 10% or.
No, it's not 10% of the population, right? I'm not going to feel really good about something being accurate unless I have at least 10% of the population I'm trying to find something out about. Right? So do we see how, like, even sometimes it's really hard to get an accurate data point on even the whole country because getting 10% of the country is really hard. Right? What else? Are there any other?
How would you write a unbiased question?
How would I get unbiased data?
Yeah.
I would assign every single person in the state of Colorado a number and use a random number generator to select them. However, the important part to consider is that am I going to be able to get a number assigned to every single person in Colorado? No. So is it possible to get a truly unbiased sample?
No.
No, but can you get close? Yeah.
Oh, isn't it when you use a little thing where it's like 10% off?
And then I'm going to be able to say, okay, hey, I was leaving this out, so I might be off by, like, statisticians, here's the thing. I don't know exactly what statisticians do. I'm going to be, like, totally honest. Stats and math are nothing, like, they're not in the same departments in colleges. Right? So I don't know what tools it is they use exactly, but I know they have tools to help them kind of correct for those things. But that's a great question. Any other questions?
We'll go for number 7.
What about for number 7? What is number 7?
A random sample of lemonade as a mean of 3.
Oh, we just did that.
Oh, is that the one that you're talking about, the 1.6?
Yeah, where I'm kind of rounding it in here.
Yeah.
Yeah?
Okay.
Okay. What else?
1%
You guys okay? All right. So just for those of you watching at home, I am going to attach links to the documents that we're using, so you'll get an attachment to the review packet and the slideshow that I had up here. Also, as an announcement, just so you guys know too, if you need an answer key for your review packet, I have it clipped to a locker out there, so you can just kind of look through it before your test on Friday if you want to check your answers. Sound good? All right, thank you all for coming. Thank you all for watching. I hope you are able to study for the test.